Okay, this equation is 4x to the 5/4 minus 12 is equal to 0. So it's an equation that has rational exponents. That 5/4 is a rational number. So what we have to do is, first of all, remember that if the numerator of this rational exponent is odd, then there's only going to be one solution instead of two solutions. When the exponent has an even numerator, then there'll be two solutions. All right, so we know there's going to be one solution to this thing. The next thing we want to do is to isolate the x to the 5/4 power. So in order to do that, I'm going to add 12 to both sides. So that we have 4x to the 5/4 power is equal to 12. Now we still need to isolate the x to the 5/4, so it's not isolated yet, so we can do that by dividing both sides by 4. So we get x to the 5/4 power is equal to 3. Now the trick to getting rid of that 5/4, to getting rid of the rational exponent, is to just raise both sides of the equation by whatever the reciprocal of that exponent is. So the exponent is 5/4. I'm going to raise this to the 4/5 power. And the reason that works is because when you raise an exponent to another exponent, you multiply those together, and 5/4 times 4/5 is just 1. So you end up with just x by itself is equal to 3 to the 4/5 power. Now it turns out that's the final answer. If we could simplify that more, we would, but we can't, because if you remember, when you take a rational exponent and convert it to a radical, if we were to do that, we would end up with the 5th root of 3 raised to the 4th power. The way that worked was whatever the denominator of the rational exponent is became the index of the radical. And the 5th root of 3 is not a rational number. So that would just end up with, if we did that, we would get a decimal that never stopped, a non-repeating, non-terminating decimal. So we don't want to leave the answer in decimal form. So the final answer just turns out to be 3 to the 4/5 power. Just leave it in that form.